50% I'm going to make the transistor work. It depends on my circuit. You have 4 portions, right? If you divide into 50%, you have 4 portions. So my transistor will be working in one among the 4 portions depending on whatever biasing I'm going to provide. Mostly it will be working in the first case, first shaded portion only. So positive half cycle, half only my transistor is going to work. So this is going to be the reason for Class C amplifiers having huge amount of efficiency. The conducting time is very, very less, and power loss is also very, very less. When power loss is very, very less, the efficiency will be very high. And as your classmate told, this Class C amplifiers will have lot of distortion. So distortion means your input and output will not be same. So whatever input voltage you give, the output signal will be completely different from input because lot of distortion added by your Class C power amplifier. So I told you in the beginning, efficiency and distortion can never be compromised. When efficiency is high, distortion will be less. When distortion is very high, efficiency is also very high. They cannot be compromised. I cannot have a power amplifier which is having a very high value of efficiency and very low value of distortion. Distortion or efficiency are directly proportional. When there is less distortion, less efficiency. When the distortion is very high, the efficiency is also very high. Okay, so efficiency and distortion, they have to be actually inversely proportional, but they are directly proportional and you cannot do anything about it. So if you are not worried about distortion, if you can compromise about distortion, you will have very high efficiency. But if you want to have very high efficiency, my signal quality has to be very, very good, then you have to use Class A amplifier only, because only in Class A amplifier my distortion is going to be completely zero. So please understand how these amplifiers are categorized and how they are going to be used in real-time applications. So you can see the diagram for a Class C amplifier, and very, very important thing you see, for base I am giving negative voltage. What will happen if you give negative voltage to base? What will happen if you give negative voltage to base? This is a very, very simple question. I am giving a negative voltage to base emitter junction. So what will happen to that junction? Will it be forward biased or reverse biased? When you give negative voltage to base, it will be forward biased or reverse biased?
Reverse bias.
Reverse bias. So your transistor will be always in on state or off state? Your transistor will be always in on state or off state? Reverse bias. Now, what is the condition of transistor? I think I am going to call your name so that you will answer, because the response is very, very poor. I thought voluntarily you will all answer, but you people are not connected to the class. I think you are just logging in and going out. I think. See, circuits without understanding, you cannot even study anything. So thorough understanding is required. So unless you understand the concept of working, you will never be able to do experiments in lab, or you will never be able to write anything in your theory examinations. So when you are going to give reverse bias to base emitter junction, the transistor is set to be off. So only when the base emitter voltage becomes more than 0.7, the transistor will start conducting. Otherwise, the transistor is going to be always in off state. I told you in class B, it is going to conduct only for a very, very short amount of time, right? So rest of the time, the transistor is kept off by applying a reverse bias voltage minus VEE. You can see it here. So this minus VEE includes that transistor is off for majority of the time. And only when the input voltage crosses this minus VEE and becomes positive, the transistor will be conducting. When the input also goes to negative, the transistor will again go to off state. So that is the very, very important thing. You, without this minus VEE, this will work like a conventional Class C amplifier only. This minus VEE is supplied to ensure that the transistor remains off for most of the time. Okay, so in the diagram you see a negative supply voltage. Some books call it VW, some books call it VEE, VBB. Anything is fine. Okay, here in the circuit diagram we have minus VEE, but in the notation it is given VBB. So it ensures that you have a negative voltage here to make this transistor off for a longer amount of time.